When I talk to people who are not directly involved in research, I often hear that they are surprised by a few issues related to how science is organized, and in particular, how publishing of research works is organized. One of their surprises is, maybe not surprises, but complaints, is that this process is not transparent. They don't know, they are not aware how this functions. Another surprise is that when they imagine a well-known professor, an expert in their field, that this professor is unable to publish his or her work without any intermediate steps. They think that somebody well-known in the scientific community should be able to immediately publish whatever they created or they described without waiting for some other processes or maybe hopping through some other steps before their work is published. Another issue is that the editor of the journal, if such people even know that there are editors in the journals, that some editor may reject a paper of, for example, this famous professor without this paper having any deficiencies. So this paper may be perfectly fine. It may be even extraordinary in that it may describe some revolutionary concepts or ideas, but still it may be rejected for some reasons. So those people, typical people, may not know why this may happen. People are also very surprised that scientists need to pay to access research works, like papers. Maybe not pay by themselves, but maybe their institution, like the university or some other institution, needs to pay. On the other hand, people are surprised that authors, scientists who are authors, are not paid. So what happens with those funds and money which are spent on accessing research works when their authors are not being paid? Something happens. And also the reviewers of the works are unpaid as well, even though they are crucial in this process of publishing scientific works. So I will speak a little bit about those surprises, but apart from these, there are also a few other surprising issues, like, for example, ethical issues, or, for example, why it takes so long to publish a paper. People are often shocked when they hear that, for example, you have to wait 1 year or 2 years or 3 years to publish a paper in a journal, sometimes even longer. So this somehow contradicts what we would expect, that science should progress very quickly and without any blocks on the way. Also, some people are surprised by the business of publishing and how much money it generates, but this is not the topic of this video. The next part of this video will be divided into 3 sections. The first one will be about showing how this entire process functions. It will be like a simplified diagram of how it works, and also how we landed in this configuration, how we landed in this situation that we have now. The next part will be about some assumptions that I came with regarding how I envision or how I imagine successful and efficient publishing procedures should work. And the last part will be showing you a prototype of a working system, so that we not only complain like so many videos, but also show something that could improve the current situation. I prepared a simplified diagram tonight, and I will use it to explain in a simplified way how usually this works. Let's assume that we have some authors, scientists. It may be also one author, and he or she or they have written a research paper, they want to publish it somewhere. They find a journal which is suitable and corresponds in the area to the contents. They decide to submit their paper to this journal, but obviously journal is not something that is alive. We need to contact some human, and this contacting person in case of a journal is its editor or maybe some auxiliary editors. And this is this surprising moment when this person, the editor, may reject the paper outright for different reasons. One of them could be that, for example, the paper is too long or the paper is too short, or maybe the queue of papers waiting to be published in this journal is too long, or maybe there is some conflict of interest. So all those reasons do not mean that there is something wrong with the paper. The paper may be outstanding, but still it will be rejected. Probably the most common reason for rejection on this stage is that the paper was not fitting the scope of the journal. Usually journals on their web pages publish the scope, and it's like a gray zone, because even though the authors may have spent a lot of time reading through the scope as described on the official web page of the journal, and they really tried to fit the scope, and they spent a lot of time, for example, formatting their paper so that it fits the technical requirements of the journal, it may happen that the editor says that, but actually we have changed our priorities. Now we value more this and not that, or maybe we forgot to update the guidelines and aims and scope of the journal. So anyway, independently of whose fault it is, the paper may be rejected for this reason and for a couple of other reasons. But if not, if the editor decides that the paper is indeed interesting and potentially could be published, then the editor will send out this paper to reviewers, and the reviewers, after some time, a few weeks, a few months, will come back with their opinion. So those narrow arrows, and the editor will gather all those opinions and reviews, and based on them, the editor will decide whether he or she wants to reject the paper or maybe publish it, or maybe the paper should be improved and worked on, and after improvements, the authors may send the paper back again for a review for the editor. Maybe the editor will decide, reading through the changes that have been made, that the paper is now ready to be published, or maybe the editor will send the paper again, this improved version of the paper, version 2, to the reviewers, and they will again review. Maybe the reviewers will be not 2, but 3 or 4, or maybe only 1 reviewer. It all depends on the editor, and this back and forth may last for a few rounds until the editor decides that it's enough and will have to make a binary decision finally. So either reject or accept the paper. If the paper is rejected, we know what happens. If the paper is accepted, it will be ready to be published. So the authors will probably prepare some final version, maybe with the help of technical editors of this journal. And once this paper, after reviews, is published, then we have readers, and readers are waiting. Other scientists are waiting to read this paper. So they would want to get access to this paper, but unfortunately, it's not so easy in most cases, because we have publisher. And publisher usually required the authors to sign an agreement which effectively prohibits the authors to publish freely this reviewed version of their paper. So they no longer are able or are allowed to do it, because now the rights are with the publisher, and the publisher decides. And this is what's often called a paywall, because you need to pay to access this version of the paper. Moreover, the publisher usually owns many journals. It may be like 1, 5, 50, 500, or even more. And what we see is some unification and monopolization of this market of publishers. We know this phenomenon from other areas in economy, so it's probably not good in the long term. So the publisher wants the readers to pay. The readers are usually scientists, just like this was the scientist, and reviewers were also scientists, and the editor was also a scientist. So they pay the publisher. Obviously, they do not pay from their salaries. Usually, their institution pays, like the university or some other academic institution pays. And since science is funded publicly, it's usually from our taxes. Money are from our taxes. If the authors do not like this and do not like their paper to be behind this paywall, they may decide to pay once a large amount of money, like in this case it was, for example, $10 or $20 per paper, like 10 pages paper. Each access could cost like $10. In this case, the authors will pay once, for example, $1,000 or $500 or $2,000 to make this paper open access. And then all the readers do not have to pay anything. So this is how it is nowadays. And especially young scientists completely do not understand this situation because it doesn't fit current times and this infrastructure, electronic infrastructure we have, and the fact that everything is distributed electronically, is streamed. So why this complex architecture with paying the publisher? As you see, all those green rectangles are scientists. They have different roles, but basically these are the same people, and all the red arrows point at the publisher. So strangely, this arrow from authors to publisher goes this way, while probably in more normal situation or standard situation, we would have arrows from consumers of some goods to producers of some goods. So we would have arrows from right to left, maybe also from right to reviewers, maybe from right to editor, but not to publisher. Sometimes, in some cases, editors get some money from the journal. Editors may also, in some cases, own a journal, and in some rare instances, reviewers also get paid. But these are more like exceptions to the general situation and general rule than something which happens often. This is a Wikipedia page for academic journal, and this may explain why we have a situation like I have showed you on this simplified diagram. You can see that this page is from Philosophical Transactions from 1665. So this is roughly when this whole concept of publishing started. And if you imagine 300 years ago, the authors probably had some manuscript written by hand. And even if they had some typewriter or something like this, and even if they would be able to duplicate it and create a few copies of their work, what would they do? What could they do? Maybe they could send out traditional letters by snail mail, traditional postal mail to some of their friends, maybe overseas or very far away. But this infrastructure was needed to prepare so many copies of this paper and also to perform the review. Obviously, everything was done using traditional means, like sending letters by postal mail, maybe using ships or other traditional means to pass information from one place in the world to another without abstracting from this physical media like paper. So this made sense, and also the publisher really had some real costs of printing, of correcting, of scanning in modern times, but not so modern, still without internet, for example. They were scanning pictures, scanning photos, and so on, and printing them. Earlier, they needed to draw diagrams or pictures, like in biological journals, for example. So indeed, there was a lot of work involved. But nowadays, the situation is different, and as I mentioned, very difficult to understand, especially for younger scientists. And probably some revolution should take place, like it took place in the music industry. Maybe some remember this Napster application, which was used to distribute, probably illegally, MP3s or music in general, and later many other similar applications were created. We also know that record labels were in this similar situation of this publisher. So since they were required to copy music, to create CDs, to create vinyl records, and so on, no musician individually, no creator, no composer had such an infrastructure to distribute and disseminate their work in so many copies. So those record labels were required to exist to help with the distribution, and also this resulted in this maybe unfair division of revenue, like 80% or 90% to record label and then 5% split between authors and musicians and composers, for example. So this is what was not liked by the authors and composers, and this is why this more direct way of distributing artistic works became more popular, even though it was initially illegal, as like Napster. This discussion about legality or not took a long time and many years. So we see the analogy to this system. Instead of the publisher, we would have a record label. Once this is eliminated, we would have direct access from readers to authors. Some infrastructure is needed, for example, to distribute revenue from readers to authors, but it should be a much thinner and smaller infrastructure than it is now, and probably the overhead should be much smaller when passing money from or funds from readers to authors, and especially to reviewers, because this is the work they are not directly involved in. It's not their work that they are reviewing, and still they spend their time to do it, usually for free. One additional information, maybe not directly related to this video, but once in a time we hear and we get some alarmistic videos about the end of science and science doesn't work and crisis in science, and usually it has to do with this green check mark suggesting that this paper only has truth and nothing more, and there is nothing could be wrong with this paper because it has been reviewed. So remember that it may be true in mathematics, for example, in logic, when the reviewers can formally verify that the paper actually is true. Maybe in physics, when you have some equations, you can verify if they are indeed error-free. But in all the experimental sciences, imagine those authors, for example, conducted an experiment which lasted like 6 months or a few years on a population of people or some animals, or maybe in some laboratory. How those reviewers could even try to verify that what the authors described in this paper is true? Obviously, they can't. So the role of the reviewers is only to ensure that this paper has enough information for some other independent researchers to try to duplicate, to replicate this experiment that has been done and described in this work. Okay? So in some cases, as I mentioned, it may be formally verified by the reviewers, but in other cases, the reviewers are only to ensure that there is enough information in the paper. And only after what was published, the contents or the conclusions are verified by many independent researchers, our belief in the truth of this published science increases. Usually it's never 100%, but at least in experimental sciences, the more replications, the more you are convinced that it is actually true. Now, the second part of this video concerns a list of requirements that describe how I see the efficient open system for processing and handling publication of scientific works. This web page is automatically translated to English, so maybe not ideal, but at least you will get the main point. So all publications are in electronic form. One system covers the entire science with all branches and fields. We forget about fancy formatting like 2 columns, 3 columns, and authors usually spend a lot of time trying to format their paper. Oh, actually, I didn't show you, but I have some traditional journals with me. So I will show you just briefly how it looked like. And indeed, some of them have very fancy formatting. Some of them do not. As you can see, some of them can be very thick. This is an example where I found a letter from the editor to me, thanking for publishing a paper from this college. So this is how it used to be in olden times. Usually you have a publisher written at the bottom, some larger format journal. All this is the legacy, some journal with more pages from 2018, yet another. So after the authors spend a lot of time trying to format their text using 2 or 3 columns and some fancy formatting, the editor may reject the paper for the reasons I mentioned. Like, for example, the paper does not ideally fit aims and scope of the journal, for example. And then the authors have wasted a few days just to format the paper. For everybody who uses the system that I envision, and I will show you the prototype in a moment, you do not need to create an account because everything is publicly accessible. But if you want to submit a paper or if you want to review a paper, in other words, if you are a researcher and you want to take active part submitting some content, you should create an account. There is a notion of optional tags. For example, if you organize a conference and you would want this system to help you with the conference, you officially register a tag for this conference, and then all the participants of the conference will tag their paper with this particular tag of the conference. And then, for example, you may manually handle reviewing those papers. This point says that all the papers are not classified into buckets like in the journals like it is now, but each paper is indexed by its contents, and the notion of similarity of topics is fuzzy. So it's like a distance. If anybody knows anything about artificial intelligence, this notion of multidimensional spaces and distances calculated from text is nothing special. This notion of a journal is no longer necessary precisely because of this notion of distance between topics or between contents of papers. Authors can always change the text with all changes publicly visible. The authors can request a review whenever they want, or maybe they do not want the paper reviewed, and then it is equivalent to this preprint. So a paper before it is reviewed, reviewers may publicly discuss with each other and with the author. So this eliminates this problem that the author is not able to explain or to enter into some dialogue with the reviewers, which often results in non-optimal decisions on both sides of this relation. Reviewers are selected in the system based on this similarity between papers. Actually, this similarity is like a fundamental property of the system, and a lot of things depend on how this similarity will be calculated. The authors may upload anonymized version of their paper just for review. It's not required, but it will help with the objective review. Again, about visibility of all the changes. If the authors decided to review their paper to create a new revision, new version, then they may ask for a review again, and then it is very easy for the reviewers because they precisely see what have changed and where. The papers get digital object identifiers. The system is able to suggest reviewers of papers. Probably it can do this job very well because it is aware perfectly of all the papers that have been submitted in the system. So it knows which author is close in its interests to each other author, how many papers they, for example, co-authored earlier in recent 5 years, for example. So the system can eliminate obvious conflicts of interests, for example, looking at affiliations, countries, communication between those authors and so on. On the other hand, we may still include human editors, or maybe not editors, but human managers or moderators, we could say, who are responsible for verifying whether a reviewer is suitable or objective or does not have any conflicts of interest with some author. The system is also able to balance the workload of reviewers globally, precisely because of knowing how much each reviewer works, how much each reviewer, meaning each researcher, spends time reviewing each paper, and also based on individual preferences of the researchers. So researchers may, for example, indicate that they are not interested in reviewing other papers because they do not have time or whatever. And the system will then not try to ask them to do the review. Then there is some measure of prestige or reputation or karma in the system based on how active each reviewer is. I mentioned moderators. Comments may be voted like we have in this Stack Exchange service, so more useful comments go to the top and it helps with spending time efficiently. Obviously, you can read all the comments if you like, but you may also read comments which others evaluated as important. Some researchers may be unhappy with the concept of journals going away, but in this system, you may as well measure success in many different ways, including who reviewed you, how positive were the reviews, and so on. So it's not like we no longer have this notion of prestige. Then about conferences, then about efficiency, which often cannot be said about existing systems, which sometimes are very old, and also they duplicate what they do. So you register for each journal of different publisher, you may need to create a new account, for example, and copy over and over again the same information. This is a very important point, that the system will never be finished and ready and stable and stagnated. The system should be developed all the time while we learn about new technologies, about new research on, for example, how people cooperate and so on. So scientists themselves should include all the newest knowledge and the best knowledge to make the system work as efficiently, as flawlessly as possible. This is why I say that we should never stop, and we should incorporate in the system all the newest findings and all the technology that appears. This is another important point about financing. I imagine this system as funded like Wikipedia in this similar model. So a foundation, international foundation, probably funded from different sources, including governments of all the countries. As a computer scientist, I know that the cost of developing this system is minuscule compared to other systems like banking systems or commercial systems. It's a very simple system. So it's not true that you need millions to develop it. Also, you obviously need some infrastructure to keep all the data in the system, all the papers, experimental data, and so on. But still, on the scale of the entire Earth and our civilization and all the countries and governments and taxes, it's like so minuscule that even not worth talking. There are so much more money spent on different ideas, including science or scientific research projects, that this is really not much to talk about. I speak about Wikipedia because I would want to avoid this system to be assigned or associated with a single university or with a single country. Because every time it happens, then we have another university or some other country which wants to compete and create their own version of such a system. So we definitely do not want this. And this is why Wikipedia is such a good model for such a system, because we may say that Wikipedia is nobody's in particular, but at the same time, it's everybody's. So everybody has a share and everybody feels that, oh, let's see at Wikipedia. Wikipedia is not associated with any particular institution. On the other hand, it doesn't exclude such institutions to cover cost or participate in funding, in providing infrastructure. We may have like a page with sponsors and mention all the sponsors, but it shouldn't be associated with some single point, like single institution or country. And it should be open source. For now, the prototype I'm just about to show you has sources on GitHub. So this prototype can be downloaded, the sources can be downloaded, improved, and so on. Adoption of the system. Yeah, so initially, of course, we may encounter problems. Fortunately, the system, as I have described it in all those points, is not conflicting with this traditional notion of journals that we currently have, because the system can be used as this repository of preprints now. So we have repositories of preprints. Researchers will be able to comment on them, to discuss them, and you will also be able to request a review in the system. If other researchers agree and review it, it still is outside of traditional publishers. It's a reviewed paper in this open system, and you still, if you wish, the researcher may still submit this reviewed version for a review in a traditional journal. Only this version shouldn't go, and only if the agreement doesn't allow you to do so, this version shouldn't go to this open system. But otherwise, a lot can be done outside of this traditional infrastructure, which also means that after some longer time, as I write here in the end, gradually we may progress and smoothly transform into this other world, which could actually be started 30 years ago when the internet first started working efficiently. The research community should have created such a system. Somehow it didn't happen, and probably our world would look quite differently if we had such a system 30 years ago. Now, the final part of this video is a short demonstration of a very simple and very buggy and unfinished prototype of such a system I described a moment ago. So what you see on this main page is some goals and motivations for this system, and also a map of researchers who already registered in the system. And this map is a projection to 2 dimensions of this multidimensional space of similarities between the researchers, and this map, this matrix of distances, or this multidimensional space, is the result of similarities between papers written by those researchers. So this is how we evaluate how similar each researcher is to other researchers. When you click it, you get the same, but in 3 dimensions. And you may click on individual profiles. But now let's register us as a new user. By the way, as I mentioned, you may see everything that is publicly available in the system without registering, but we want to do something more. So we create a new user, so we sign up. Let me write down my details. Here it says that if possible, you should use an institutional email address because it helps with endorsement, because you may be endorsed as a researcher either by confirming you as a researcher by other researchers, like 3 other researchers may say, okay, this guy is indeed a researcher at our university, and then you are promoted level up from just a regular user to a researcher, and you may perform reviews and submit papers, or you may be considered a researcher purely based on your email address. So I will use my email address from my university. And frequency of notification. When others post messages under my papers, I want to be notified every 1 day, 3 days, 1 week, and so on and so on. You will get notification anyway when you log into this system, but you may also prefer or wish to get email notification. So let's leave it with 1 day. I agree to privacy policy. At the bottom of this page, you have about the system, simple help, privacy information, contribute, meaning how you can contribute to develop the system, and not just to contribute a paper, meaning this means how you can contribute in the development of the system. A simple forum, contact, I'm not a robot, and create account. Now we are waiting for a confirmation email. We got it. And you have confirmed your account. So now we can log in. We sign in, you logged in. Okay. Now when I go to my profile, my researcher profile, I'm already validated as a researcher. So I have slightly more abilities compared to what would happen if I just registered without being endorsed as a researcher. First of all, let's edit our profile. Drop your profile photo, photo dropped. About me, optional. My interests, an ORCID number, here it is. Google Scholar, ID, here it is. Affiliation, here it is. Personal website, frequency of notifications, and limit on the number of review requests. This is important because, as we know, the scientific community or research community relies on peer review. So if you indicate that you don't want to participate in peer review, you should not also expect that your papers will be reviewed. So this is where you indicate how many requests you would want to get per month. Let's say I accept 1 request. I save changes, and this is how my profile looks like. 0 papers, 0 reviews, 0 comments, and initial reputation points, so to say. Edit profile. Now something very important, calibration papers. Calibration papers is how the system knows what is my area of expertise and what I'm working on as a researcher. Those papers are never published. Only they are used to extract text from those submissions. So you are free to use any papers which have already been published, and even if they have some agreements which do not allow you to publish them openly, because they will not be visible outside of the system, as I mentioned, only extracting text. So one uploaded and the second one uploaded. Two papers, you uploaded 2 calibration papers, maybe consider adding a few more, because obviously the more, the better. The system will know where you are in this multidimensional space of all the researchers, and will be better able to estimate similarity to other researchers, to judge whether you should evaluate some other works or not, or maybe also point you towards other interesting works written by other researchers. Okay, I will stay with 2. Since I'm talking about this similarity or distance in this multidimensional space, I mean this one, we have tested many measures, including large language models, because the ultimate idea behind this similarity measure is that if 2 researchers write 2 different papers in 2 different languages using different sentences and different order, but describing the same concept or the same idea, this similarity measure should consider those 2 papers as the same thing, basically. So I'm just saying that we compared a few measures, and obviously assuming that many researchers are listening to me, including AI researchers or text processing researchers, they will know what I'm talking about and how to do it better, and also how to do this visualization better, because sometimes you see those huge maps of all the science. So this is basically the starting point of one group of researchers shown in this small sample, probably one tiny area in this entire map of the entire science. Now let's submit a paper. My papers upload paper. Okay, so you upload your PDF, you upload optionally an anonymized version and certify that it is indeed anonymized. If you upload this one, then this one will be accessible to reviewers, but you do not need to send an anonymous version. A title and an abstract, a license. You add the remaining authors. Optionally, you assign tags. I mentioned what is the role or the function of those tags, maybe affiliations for the paper itself. You declare that you have no conflicts of interest, or you describe those conflicts of interest. You indicate that you are aware what you are submitting, that you do not violate any agreements, as I mentioned, and optionally, you may also indicate that you want this paper reviewed or not. If you want this paper reviewed, then you indicate how many reviews would you want to get, which also is definitely correlated with your willingness to review papers, because of peer review. You shouldn't probably expect others to review your papers if you are not helping others as well. Actually, this could be even in such a system linked and dependent on each other. Like, for example, every review you make allows you to request somebody else to review your work. Such an idea. Since I speak about reviewing, let's now show you an example of how a paper review looks like. So I enter my profile. Let's assume that somebody asked me to review their paper entitled Lorem Ipsum. Mysterious title. Okay, so I see their paper, and I can add remarks not just in a text file, but assigned to particular places in this paper. Like, for example, save. And this is the list of my remarks associated with specific locations in the paper. Something like this. And maybe one more remark without location in the article. Okay. So those remarks will be visible to everybody since they are open. And then I may adjust evaluation criteria for this paper. I am a great believer in continuous scales. I do not like limited scales like low, medium, high, which often are used in reviews. Okay, so novel and substantial compared claims justified, free of essential technical errors, were organized. How confident I am. So my weight of being confident and binary accept, not accept. Obviously, this is just an example. I definitely am not showing you this prototype as some ultimate solution. As I mentioned, I imagine the scientific community could come to some consensus and conclusion and use it as a best choice or a few choices, depending on what they decide on how it is best to evaluate scientific papers. And I'm sure there are a lot of research works on this, precisely on this, and there are some conclusions. So those conclusions could be implemented or should be implemented in such a system. I want my review to be anonymous. In hide review, you can change it whatever you want. Okay, so this is it. Let me save. The review has been saved, and now I'm on the page of this paper. You can see this tag assigned to this paper. So the author assigned a tag to this paper. It looks like some conference name, for example, and we have reviews, and those are weighted averages. Obviously, they are not calculated properly now, just placeholders. So anyone proficient in programming can easily fix this to make those numbers properly calculated. I can look at some other reviewers and see what they didn't like. Too small font. Okay. The evaluation of some other. And I can also comment on the review itself if I want, and other reviewers and other researchers in the system as well, and authors as well may ask, for example, if something is unclear or maybe they want to clarify something. Recently, you see more and more of such open systems to be created, and it's very good because at least we start some competition. I mean, the competition is not so good because ideally we would want to have only one such system, but it should have been created 30 years ago, as I mentioned. But at least we have some competition in this area. I will just reiterate that this system should never be finished and ready and closed. It should be alive, it should be adopting, it should be evolving all the time as new technologies appear and as new findings, research findings are discovered. I mean, the findings that influence the working of the system itself, how to make it more efficient, knowing how people cooperate, for example, knowing everything about social interactions, and so on and so on. Also, law, for example, may change. So, obviously, this system should observe current law. I have written down a few areas in science and disciplines that should be involved in the development of such a system, not only computer science, but sociology, psychology, cybersecurity, law, databases, distributed systems, user interfaces, data analysis, artificial intelligence, and so on, so on, so on. Everywhere you look at the system, you see that things are not done optimally and are not done properly and could be very easily improved. But this must be a community enterprise and not just a few people. I mentioned many times we should have done it a long time ago. Unfortunately, if we do not do it, then we may see a similar phenomenon that happened in AI, that even though it's the researchers in academic institutions who develop new AI concepts and new AI algorithms, still it's the closed source companies who benefit from this and get a lot of revenue. And unfortunately, with AI, it's more risky because at some point, those companies will have intelligence advantage over universities and over scientists. So this is very uncomfortable situation in case of this system of publishing and managing science in general. There is no such danger because everything gets published anyway. We only need to pay for this to access those works. And okay, nowadays maybe this restriction is loose. There are some illegal initiatives like stealing those works and publishing them on open servers and so on. But still, we should do it as soon as possible because we are 30 years late. I will include a link to this text I was reading in the description of this video, so you can read it slowly and agree or disagree. I will also include a link to this GitHub repository, so if you know somebody or some student project or a PhD project, if you wish to be involved in the development, you will be able to. I encourage the scientific community to take part in the development of such a system or a similar system, and take care.